Good evening, everyone. Thank you so much for joining our panel discussion this evening. Please bear with us a few seconds. We are waiting until our second panelist join our session. Please bear with us. Rakita, should we start? Meantime, Ross can join in.
I think he's trying to connect, right?
Yes.
And see you connecting.
We'll wait for a few seconds and start.
Yeah.
Maybe he can join in later on.
Yeah. Yeah.
Okay. All right. Good evening, everyone. My name is Tharanga Piris, and I am a lecturer in School of Computing at IT. I would like to welcome all of you for the panel discussion on the topic of delivering artificial intelligence and machine learning in enterprise software. We are happy to conduct this discussion as a collaboration with IFS. First of all, let me introduce our panelists for this evening. First, we have Mr. Rakita Karunaratne, who is a senior architect and a part of IFS research and development team as well. And we also have our second panelist for this evening, Mr. Ross Parking, who is a principal architect and also a part of IFS research and development team as well. He's joining with us today all the way from UK. During today's session, our panelists hope to provide a brief about the use and applications of artificial intelligence and machine learning in enterprise software, and also how business processes can be optimized by these technologies. They also plan to discuss some solutions in detail as well. A warm welcome goes out to all our audience this evening. At the end, we will dedicate some time to interact with all of you as well. However, during the session, you all are welcome to use the chat option and send us any clarifications and questions you have regarding the topic as well. Without further ado, I would like to invite Rakita from IFS to set the stage and start the panel discussion. Rakita, over to you.
Yep. Thank you very much for the introduction and good evening. And so before I begin, let me first share my screen and start sharing the slides. I'm connecting from home, so you might hear some noises from the background. do I share my screen? Yeah. Okay, so we are having some technical difficulties with Ross connection. So until he connects, I'll continue the presentation. And yeah, so basically, welcome to this discussion on delivering AI and machine learning in enterprise software. And what I'm going to do is we'll first talk about the opportunities that we have in the business software domain to apply AI and machine learning. And I will go through an overview looking at various business domains and what we can do with AI and machine learning in these domains with some examples. And then in the second part of the presentation, my colleague Ross Parkin will discuss some of those capabilities in more detail. So yeah, but before we begin, I'll first lay out some terms that we will come across this presentation again and again. One of them is obviously enterprise software. So if you look at a dictionary definition of what is enterprise software, it would say that enterprise software is software that is designed, developed, and implemented to fit the needs of an organization as opposed to needs of an individual. And you would talk a lot about things like structured and unstructured business data, a lot of transaction processing, various business functions, and also various analytical processing, reporting, and integration with other systems. And generally speaking, these are things that are possible with traditional computing. And when we talk about artificial intelligence and machine learning, we generally talk about things that are traditionally not easy for computers, but they are traditionally done by humans. But with modern developments in computing and various algorithms, today we are having capabilities like computer vision, natural language processing, autonomous agents, deep learning, machine learning, data science, big data, and IoT, and all these things make it possible for computers to do things that were earlier only possible by humans. And the question is, how do we bring these two worlds together? On one hand, you have capabilities like computer vision, natural language processing, and autonomous agent, things that make completely new capabilities possible. They disrupt entire industries. And one of the things we can do is to integrate some of those capabilities into our business applications. Not necessarily to build same capabilities in the business applications, but integrate with those platforms to open up new use cases. And another side, probably more important for existing software vendors in the enterprise domain to look at is that we as enterprise software vendors provide platforms to customers who gather and collect massive data assets over years and years. And these data assets can be used to train and use machine learning models or AI models, which could be used to make various predictions and various analyses and run simulations, and eventually help us make better decisions, or if you want, even fully automate certain workflows. On top of that, you can integrate those internal data sources with external data sources like mapping services or weather services or any other data source that is available out there, and then use those combined data to train various models and have automated AI-driven workflows. That is not just aware of your business, but it is also aware of the outside world. Okay, so with that, we'll talk a little bit about this age-old question. When we talk about AI and machine learning and some of these more recent technologies, we often get this question of, are we talking about are we talking about augmenting the human being? And one thing to keep in mind is that AI or machine learning is not general intelligence. You can train a model to be good at certain tasks. And as long as that is a relatively repetitive task, and as long as you have enough volume of data to train the model, AI and machine learning can add value in that particular task in your organization. And also, it can be better at deterministic algorithms in certain problems like optimization problem. And also, if you have problems where you require to go through a lot of data, a lot of different parameters to make a decision, and you have very little time, and in that kind of situations, AI or machine learning can do better than humans, and most of the times better than deterministic algorithms as well. And we will talk about some of these examples later. And also, I mean, if you look at the humans are better at general intelligence. We are better at handling unforeseen conditions. And also in business, you need to have authority and responsibility properly tracked when you make decisions and take actions. And that's something you have to have humans for. And as a result, more often than not, you would find situations where you have machine learning and AI which provide information, analysis, predictions, and end of the day, a human user has to look at those things and also look at other factors and then finally make a decision. So generally speaking, in an ideal world, you will have machine learning and AI where it adds value and humans working side by side with those platforms and tools where humans add value. Just to give you an example, one possible use case is imagine that you have a voice-enabled automated menu system that you have in most of the call centers in banks and various service providers which have to serve a lot of customers, and usually nobody likes to talk to those menu systems. What if you replace that with the AI-enabled chatbot, right? And then you can have the conversation driven by the customer instead of having to go through an automated mechanical menu. And this bot can be data aware, it can be data driven, and it will know the data related to the customer that it is talking to, and the interaction can be very specific to that customer's requirement, and it can do most of the repetitive and common tasks that the customer wants to do, leaving the human operators to handle very specific non-repetitive tasks only. And what that will do is that will reduce the load on human operators, it will reduce the waiting times on the call center, and at the same time it will increase the capacity of the call center without having to increase cost. So everyone benefits at the end. The key is the AI and the humans has to switch seamlessly. Okay, so with that example, we'll go through a few possibilities that exist in different business domains, starting from supply chain. But of course, this is by no means a complete list because in reality, the possibilities are endless. So if I start with supply chain, we can have models that pick suppliers for the products you need based on their past performance, various risk factors, and you can train models that can predict the probability of success or failure on various business deals. You can have models that predict delays or potential problems in orders by running various simulations considering various conditions. And like I said earlier, we can have automated communication platforms that are much better than voice menu systems to interact with customers and suppliers. Also, we can have models that perform things like demand planning and forecasting, where you can look at the past demands, the seasonal demands, and also external factors like weather forecast or weather changes, and even competitor activity to predict what kind of demands you will have on your systems and plan for it. And we can tie all these together using automation, where when you get a demand from a customer, you can trigger various activities within your organization, in your suppliers, in your contractors, and you could also do things like credit checks or quality checks, going beyond what we can traditionally do with simple rule-based workflow systems. Moving on to manufacturing, one of the key challenges we have in manufacturing is planning and scheduling, where we have to plan our manufacturing work in a way so that we don't miss the order dates. We get all the material we need on time. At the same time, we have to minimize the cost and we have to maximize the productivity of our machines as well as the people. And this is traditionally a very difficult problem for deterministic algorithms to solve. And this is a place where AI and machine learning can really help. Before that, we had humans doing with Excel sheets, and now we will talk about later in the presentation how it is done with modern optimization systems. And most of those industrial machines are capable of sending telemetry data into other systems, so we can use these IoT streams with trained models to predict their performance, potential failures or breakdowns, and even predict required maintenance. And we can incorporate that data into our scheduling systems or optimization systems so that we can plan maintenance as well as the manufacturing work seamlessly without causing disruptions to our deliverables. And on top of that, of course, you have demand planning and forecasting and also automation, just like we had in supply chain. In asset management, we can have digital representations of our assets or equipment in our business system. We call them digital twins. And then we can use that data to run simulation and incorporating their IoT data streams and various models trained with those data. We can predict their performance, we can predict their breakdowns and also maintenance requirements. What that will allow you to do is that it will allow you to move away from traditional calendar-based maintenance schedules. In those traditional calendar-based maintenance schedules, you have to have planned maintenance downtime regularly for your equipment, where you check the equipment and do required maintenance. With predictive maintenance, what you can do is your machine learning models or your prediction systems will predict the maintenance requirements, and then you plan your maintenance using your scheduling algorithms, and then only you will take down the machine to do the maintenance. What this does is it minimizes the maintenance downtime required and it maximizes the productivity time of your equipment. And with proper scheduling and optimization, you can optimize that maintenance schedule by looking at your manufacturing or production schedules as well. And you can also optimize the productivity of your maintenance teams. On top of that, you can have things like augmented reality, voice activated access to your business data, so that the maintenance teams that are traveling outside of your office to run maintenance jobs can access the data on your system directly without having to sit in front of a computer and without having to talk to another human being. So last but not least, I'll talk a little bit about optimization. Optimization itself is not a business function, but it is something that you will find across many, many business functions. You will find it in manufacturing, you will find it in maintenance, you will find it in anything that requires travel planning, and you have it in material requirement predictions or job requirement predictions, and also in simulations. Traditionally, again, I mean, this is something that was done in the Excel sheets by human users, because this is a very tough problem to crack for traditional algorithms. But with machine learning and AI, this is an area that we can really improve on, and this is also a big investment area for business applications, because you will find these patterns everywhere in businesses. So to continue to discuss on this topic further, I'll hand over to Russ Parking, and he will continue the presentation on more details on optimization. I hope Ross is connected.
Hello.
Hello, Ross.
You hear me?
Yes, shall I run the slides for you, or do you?
Hi.
Sorry.
Okay. If you could, yeah. Sorry, I've got a bit of a poor connection today.
Okay,
so yeah,
well.
next slide, please. Okay, so in the previous slides, Rutger's gone over kind of some examples of where we could fit AI optimization and machine learning into the business domain, and some interesting examples there. And so in the following slides, I'm just going to dive a bit deeper into a case study of kind of one of our pieces of software, what problems we're trying to solve, and how we go about doing it, and the benefits actually that the customers see. So I think it's quite an interesting case study. So when we look at optimization, as Rutger said, there's a few major key things. So obviously the customer has demands within their business, and obviously these are complex things that they're trying to do. Traditionally, yes, they might use pen and paper, or they might use some kind of a basic IT system, like Excel spreadsheets, but they really want to step it up, and that's kind of the stage that a lot of leading enterprise businesses are at. They want to see business value realization. They want to move towards automation, and they want to remove repetitive work. Next slide, please. You can just click all of the bullets on this one, please. So yes, so we at IFS, we have a product called PSO, which is Planning and Scheduling Optimization. And this is kind of taking the concept of an optimization algorithm and making it into a business application. And I think that's kind of a really interesting angle, because that's where a lot of value can be reaped. We do see, you're probably all familiar with that there's algorithms and that there's very academic studies of them on test cases that there's known solutions, or there's a competition on who can do the best on a particular problem. But in real world business, there's there's customers, they have a different problem every day, so you have to morph these academic solutions into something that can apply to business and be reliable. So what we have is a product that's had considerable amount of investment over the years from PhDs and people who come out of university with scientific and mathematical backgrounds, and a huge amount of domain knowledge has gone into this software as well. And what we've ended up with is a best of breed solution that's been written in such a way that it's reasonably abstract and can be applied. It's multi-purpose, can be applied to a wide range of business domains, and it scales extremely well. So if I've got a chance, I'll talk about the architecture a bit. Next slide, please. So scheduling is quite complex, and this is, I'd say, the main area that we focus on is field service, and that really covers. You could think of a standard example as an engineer in a van trying to go around and fix appliances, or it could be air conditioning, it could be a plumber, it could be electricians, something like that. And basically you have a fleet of what we call resources, and then we have work that needs to be done, or work orders, that's the WOs. Now, the complexity of that problem in an academic sense, it's similar to what's known as the travelling salesman problem, but this is another term, the multi-vehicle routing problem with time windows. So that you can see the complexity of the numbers here dictate the number of possible solutions if you were to try and solve these problems in a brute force manner. And it obviously scales very badly. You know, even with 5 engineers and 30 jobs that need to be done, there's a huge number of possible solutions. So brute force approaches don't really work. So we need intelligent, approximate solvers to deal with these problems. Next slide, please. And this, I'll just go through this one quickly. I mean, there's quite a lot on this slide here, but what we see is the reality of applying these algorithms to real world business is that, you know, real customers have a huge amount of complexity. They have constraints, they have requirements, they have things like parts, and their engineers have different skill levels. If the work is location based, then there's distances, travel times, cost of travel, all sorts of things that come into it. So we need to find a way of taking essentially academic algorithms that solve numerical problems and incorporate all of these kind of constraint-based rules. Next slide, please. But the good news is, once we get this right, we do actually see, and these are kind of average numbers that we see from our customers. So we can see that if we use automation or intelligent algorithms, customers can typically see huge reductions in, say, the average cost per job, 76% reduction. They can automate a lot of their optimization and scheduling, 99%. And travel reduction times can come down as well, because rather than having someone moving rows around on a spreadsheet, you've just got an algorithm that will automatically do that in the background. Next slide, please. So how do we do this? I mean, roughly what we're doing is solving an objective function. And what we do, we model the business in terms of gains. So things that will increase the service margin. That's like value for doing work, benefits, multipliers for various constraints that we tick. And then we balance that against the costs of performing work. So things like the cost for specific engineers, travel costs, costs for bringing engineers in to work overtime. And then the difference between these gives us a number, and that's what we call the service margin. It's essentially the solution to the objective function, and that's what we want to optimize. So it sounds simple when you put it like that. Next slide, please. So I've just got a few screenshots here of what the software looks like. You'd probably be able to relate to this a bit more. So these lines on the map here are, and there's the dots. The dots represent work that the engineers need to do, and the lines between them are the travel, A to B travel. And the solution that we've got here is an optimum set of routes that reduce costs and maximize the margin. If we click onto the next slide, we'll see the other screen. I mean, then these two screenshots show the two screens that the operators in the control center for our customers that they would see. We often call them the dispatcher, because they'll be the person in the back office that the engineers will call to talk about their route for the day, if there's been any problems, to make sure the system gets updated if it needs a manual update. And this is a Gantt style screen that you can view all of the work side by side, and it's showing time on the horizontal axis, and each of the rows on the vertical axis are different engineers, and the little blue lines that's the jobs that are being done throughout the day. So this is basically what the operators will see, and this is the solution that the algorithm returns. Next slide, please. So where we're at really, and I think this is kind of an interesting general view is that a lot of customers, and we keep coming back to this point, we see complex problems being solved with essentially, entry-level IT solutions, kind of Excel spreadsheets or basic algorithms. And what a lot of businesses want to do is they want to get up this curve. So this is the journey that you can take. And here it's applied to optimization, but this applies to kind of any business domain where we want to introduce intelligence, automated intelligence. So may it be optimization or machine learning. And the examples here that show that as the customer embraces this technology more, the benefits that they see will drastically rise, and they can eventually have essentially an automated system where they can, in the case of scheduling optimization, they can just drip feed the work in as it comes in through the day, and the system will, this software in particular, will dynamically respond to that, and they'll get automated scheduling in the background without needing any real manual interaction. And that's where we want to get our customers, so they can really see benefits in terms of change management. Next slide, please. Now, talking about how this software is built, we say it's built for scale. Really popular architectural approach at the minute is microservices, where you split your system up either using some domain-driven design or technocratic design approach, and you define, rather than having a monolithic application, you will break your application up into microservices where you have many services, each with a specific responsibility. And the goal of that is to allow different parts of the system to scale independently, to align with one of the basic rules of cloud computing of horizontal scaling for different levels of functionality. Now, we're also at the point in time where most applications will be hosted in containers, and work can then be load balanced across stateless services in that kind of architecture. Now, the application I'm talking about here, PSO, it has many attractive features. It's multi-algorithm, and we've architected it in such a way that can be applied to many business domains. But yeah, the key thing that comes out of this and what's made it successful is that customers do see unique business value, and that's kind of a leading seller for us. So next slide, please. On this next slide, just got some kind of a summary from a real world customer called Cubic, and Cubic, they essentially run maintenance for the London Underground, which is underground train system, has a high level of traffic. There's lots of people use it. It's critical if any of the ticket machines break. So one of the Cubic's main things is they service the ticket machines. And what they needed, and what we've worked with them to get, is essentially more than 95% automated system where they have sensors on the ticket machines that alert if there's an error or something, and that automatically creates work orders in their ERP system. Those work orders get fired into the scheduling system and are automatically scheduled. There's an automated dispatch system, which then can, based on rules that the customer has set, dispatch the work to engineers in the field. The engineers can then pick up the work, they'll get it sent to their mobile device, and then they'll go and can attend to any repairs that need to be done. And all of that happens without any manual interaction. And basically this has allowed Cubic to scale their operations, because if they get more customers in, or they want to cover different underground systems, they don't need to hire more dispatchers in the back end. They just need more engineers. So their system, their company can scale, and this has been really beneficial to them, and they've managed to seal some huge contracts because of this, which it's a really nice result, and it's great to see this helping customers. Next slide, please. So how do we put all this together? How do we bring optimization and AI and everything together? So basically we have things like sources or client applications, so user interaction, IoT, or just data feeds that are pulling data in. And the key word here is data. We've either got work orders being created that fire data in, or we have data stores where we are collecting data from these feeds, from these inputs, and then we need to keep a hold of that data, and that data is essentially the food that our algorithms need, be it the inputs for optimization, or be it the training data for kind of classic machine learning approaches. And I'd say even if you're using an approach like reinforcement learning, which is relatively lighter on a data source, you still need some data or some business knowledge to feed that system. So once we've got the sources and the data storage, we then have to architect our system to have back-end services that hold the business logic. And those systems need to be scalable, distributed systems. And that's basically because our customers need their business to be able to scale. We don't want them to have ceilings on their architecture. It doesn't really go down well with many customers. And once we have that kind of architecture and the data put together, that's when we can start to enjoy ourselves, and we can embed AI and machine learning into the various tiers of the application. They could be in terms of intelligent assistance in the client tiers, or assisted decision making in the service tiers. And some examples are things like model training and predictions to give automated decisions, optimization, NLP, and anomaly detection. Next slide, please. So as an example, here's a use case that for machine learning that we've worked on relatively recently. So for customer relationship management, this is all about logging essentially prospects that a business wants to keep track of their prospects. And what they want to know, or what would be really valuable for them to know, is this a worthwhile prospect? So given the information I have, can I train a model, a machine learning model, if we've got some what we call labeled data, historic data, where we know whether we won or lost a particular business opportunity, can we train a model that can then, given a new business opportunity, make a prediction and tell us whether we're likely to win, and at the same time, can it give us the percentage of success or failure? So here we can train a model as just a little snippet there. You need significantly more than 10 rows of data. I mean, we're talking tens of thousands of rows for these models to be starting to get anywhere near reliable. I mean, big data does help in these cases. And then when we enter a new business opportunity into the system, we can make a prediction and present that back to the user in the UI when our operator has entered that in. Next slide, please. So obviously, as we move towards this kind of magic decisions that pop up into applications at the client level or in the backend services, there's always this question, there's always human doubt, I suppose, that why did the application make this prediction? Why did the model do what it did? And this is natural. I mean, we all kind of want to understand why things have happened. And as we automate things more in business applications, it's not just a human nature thing. This actually has legal and ethical implications. And businesses now kind of demand for trust and transparency. They may need, in certain business domains, they may need accountability and explainability from their algorithms. So this can come depending on the type of algorithms you're using, but in the case of machine learning, some algorithms can be constructed in such a way that they have inherent explainability. So for example, rule-based classifiers or decision trees, it's say a little bit easier to poke into the inner workings and see what path has been chosen in making a decision. And there's also a different approach where we use kind of a separate family of algorithms to post-process models and use an after-the-fact approach. And the kind of things we want to get out are basic things like which of the columns that we fired in have driven the decision, or what were the competing sides of the coin when we made a particular decision through the path of all of the columns that could have been chosen from. Next slide, please. And as an example, this is kind of what we're getting here. So we have explainable AI. So on the top row, we've just got vanilla AI, where we take training data, we train a model, and we have a predictive model. And what this is going to say is, let's say we fire in pictures of cars to an image-based classifier, and we've trained it on pictures of cars, and it will say this is a car, right, rather than this is a duck or something like that. Now, what we want to get from explainable AI is that we train them, take the train data, and then we either have an explainable model or a normal model and some explainable algorithm that we can wrap around it. And that ends up giving us an explainable predictive model. And as an example, let's say we send in a picture of a monster truck, say this is a car because it has 4 wheels. Okay, so it could be that it's picked out some features on it within the image, and that's kind of been key because kind of in the industry, some of the historical doubts around these algorithms are how do image-based classifiers work, particularly with neural nets, which are quite difficult to disentangle. There's been a lot of work put into understanding those algorithms. Next slide, please. And kind of coming back to an example with tabular data, if we were to look at credit lending, where we take information about people applying for bank loans, and we train a model on that data, and we end up with an explainable model, and then we want to make a prediction to see if we have a new customer and they've given us their details, and we want to know, and the algorithm will make a decision whether this person is creditworthy or uncreditworthy. But we want to know why it made that particular decision. So in this case, we've got a graph here of what we call feature importances, and from the bottom to the top, it's going the most important to the least important. And the most important feature in this case was annual income. So the big
Hi Ross, I think you are breaking up.
Audience, please bear with us. We are trying to sort out what was the connection error from Mr. Ross's end. I think he's having a technical issue at the moment. In the meantime, I invite all of you to please use your chat option and send us any queries, any clarifications you have. Today's session was open up for targeting undergraduates as well as newly passed out undergraduates who have recently pursued a career in the computing industry. So I'm sure you all have a lot to get insights from, industrial insights from these two industrialists from IFS. The chat option is all yours. Please do send us your queries and clarifications. We should be able to facilitate them at the end of the session. Rakita,
Yep.
until process technical issue gets sorted, should we give some time to answer some of our audience's questions?
Yeah, sure. Yeah.
Right. Okay. So this is one of the questions we have received this evening. So this particular participant would like to know the future of AI and machine learning in the enterprise software industry. What can you say about the future, and what can we expect from enterprise software with the addition of AI and machine language?
Yeah, I think one of the things I'm just trying to chat with Ross, by the way, to inform about the connection problem.
Right.
Just give me a second. Yeah. Talking about the future, I think some of the big things that we are seeing is that a lot of businesses are trying to get the machine learning and AI incorporated into their decision making. And also, I think we sort of made a slide to discuss about that. Let me see if I can open that up. So this is what Gartner has predicted when it comes to what they think what will happen in the future in AI and machine learning. If you look at this curve, you can see the things that I've already getting close to maturity. And over here, we are seeing things that are quite a long time ago. So for example, things like ontologies and graph-based systems and identity-related things are already in commonplace. Like, for example, you have various identity mechanisms using biometrics and things being commonplace. And then you have AI-related augmented development coming up, but it's at very early stage. And if you look at things like what do you call this, general intelligence, that's actually quite at the beginning stage. So if you look at artificial intelligence specifically, you can see the general intelligence is in a very infant stage, and they're predicting like it'll take more than 10 years to get there. But when it comes to things like cognitive computing, autonomous vehicles, they are almost there. And I mean, of course, you know that it's already in the market in some capacity. So what we are seeing in the business domain, if you really look at that part, we will see more and more AI adaptations in terms of data entry, automation, scheduling, planning, and optimization, and also some decision making. We don't have fully automated decision making right now in a lot of places, but more and more into the future, we will probably have more automated decision making based on AI platform. Yeah. So that's what I'm seeing in the industry for the future.
Thank you, Rakita, for that comprehensive answer. I think we have time for one more question. Okay, so there is another question that came up with one of the audiences as to, I'm assuming that this is an undergraduate. So he wants to pursue a career in the software engineering field in the near future. So he would like to know from an industry expert like yourself, what are the things that he should be equipped with? What any knowledge bases that he should be prepared to undertake in order to pursue a career in enterprise software development related to AI and machine learning?
Okay. I think that question sort of covers a part that Ross was actually planning to do in his presentation. Unfortunately, we got him disconnected. So maybe I'll go back to the last slide. Actually, he was planning to show. I mean, he was here when he got disconnected. So I'll just jump to next slide. and discuss that part for him. So if you want to get started with AI and machine learning in enterprise, I mean, one part of the problem is you should be able to explore algorithms and data at a prototyping and experimental level. Before, I mean, that's how you first come up with your models and figure out, okay, which algorithms are going to work best for the problem at hand. For that, we would usually use Python-based tools and platforms, which are very popular for machine learning and AI. Python has sort of become the de facto language for these things. So these are the tools and platforms you might want to learn when you actually want to figure out, okay, what machine learning models and what AI models that we can create for specific problems. And while it's possible to build applications with Python directly, if you look at enterprise domain, you would find that we are using a lot of backend systems, a lot of databases, and we are using a lot of strongly typed languages like C# and Java. So while you discover your solutions using Python and various platforms that are based on Python, when you are taking that to the market, you would want to bring out some of those capabilities into those strongly typed languages and their platforms, or create integrations between these platforms. So that's the other side of it that you will have to study and get good at when you are implementing these kind of things. But of course, depending on the organizations that you join, you might have different people doing this. You might have data scientists exploring data and creating models, and then you might have data engineers who are actually building the final systems. But in some organizations, you might have same people doing all the work. So yeah, you have to sort of bring both of these worlds together in reliable, robust applications that can also scale into larger platforms. Yeah.
All right. I hope that answered this particular audience's question. So that brings us to the end of a successful session. And I'm happy to say that even with a few technical glitches, our panelists managed to deliver a very comprehensive and informative session for all of you. So thank you so much for your participation, and thank you so much, Rakita, as well as Ross. So I think these technical glitches are quite usual and normal these days during this pandemic. So thank you, Rakita, for even covering up few segments that Mr. Ross could not cover due to his technical difficulties. Thank you so much, Rakita and IFS.
Welcome.
And I hope that we could reach out to you for future similar sessions as well. Thank you so much.
Yeah, and thank you very much for having us. Yeah. Thank you.
Thank you so much, audience, for your participation. And we hope that this session was a very informative session for all of you, which will be important for your future career and your current studies as well. Have a pleasant evening. Thank you.
Thank you. Bye-bye.